So now we're going to look at what's going to happen on the exterior angles of a polygon. So this means the outside angles. So what I'd like us all to do is start with this triangle. Now what you are going to do is extend the angles, or extend the sides. So what I mean, go ahead and take this side here and extend it out, like that. Take this next side. I'd like you to extend it out. And take this next side and extend it out. Something like that. That seem okay? Okay. So, using our knowledge of linear pairs, can we figure out what each one of those angles is? Jerome, I feel like you're going to be a good source for this one. What is this one at the top going to be? You're usually good at this mental math. 130. Next one, 105. And then the last one, 125. So then what I'd like us to do is those three angles that we marked in, I would like us to add them all together. And what did we get? Okay. Are we good so far? So, I want to do it again, except instead of a triangle, let's do this with a quadrilateral. And I'm going to let you all kind of work through this for a minute or two, but this is what I want you to do. Extend this side, extend this side, extend this side, extend this side, and find those four angles and add them all up. Hey, I'll give you like a minute or so to do that. As I was walking around, I was seeing kids filling all this in, and when they added all those together, they got 360. Interesting. So even with a three-sided shape and a four-sided shape, we still got 360, correct? What about a five-sided shape? Do you think it's still going to be 360? No? Maybe? I don't know. Try it. Do it. Let's see if this works with the pentagon. So, you're going to take every side and you're going to extend it out like that. And I want you to find those five pieces, those five angles, and add them all together and see what you get. So I walked around, I saw a lot of kids working on this, and what I saw, I think these are right, that if you add all of these together, you still get 360. Do you think that's going to work for all polygons? You think so? Okay. So this is what I'm going to write for you guys. So I think the answer is yes. Sorry. Wait. Yes. Yes. Probably. Do you think it's going to work? So yeah, probably. Probably. So for any polygon, and here's the official conjecture, the sum of the measures of a set of exterior angles, so that's the outside angles, so the outside angles is 360 degrees. Doesn't matter how big, how many sides a shape has. So we're going to write a little note. Are you ready? Okay, write this down. Regardless of the number of sides, So it does not matter how many sides it has. The exterior angles of a polygon always, let's underline that, always add to 360. So let's keep going with this. If we know that in every polygon the exterior angles sum to 360 degrees, do you think we can find one exterior angle? And the key thing is one exterior angle in a regular angle. Do you think we'd be able to do that? And the answer is yes. Since all of the angles in a regular angon, remember that word regular means equal sides, equal angles. So since all of the angles in a regular angon are equal, comma, all the exterior angles should be equal. So since all the inside ones are equal, all the outside ones should be equal. Does that logic kind of make sense? Since we're just doing 180 on all of them, it's like, well, if all the inside ones are the same, all the outside ones are the same. So for example, let me just throw it out there. If all the inside angles are 150 degrees, what should all the outside angles be? How do I get from 150 to 180? Okay, don't draw this. Let me draw out an example. So because I think I'm trying to ask too much of you. If I knew that all of the, don't write this down. If I knew that all of these were 150, what does that mean about all of the outside ones? They're all going to be 30, right? So regardless of what the inside is, let's say we knew that all of the inside angles were 170. What are all the outside ones going to be? 10. Okay. So we're going to use that logic to help us answer this question. So all of the outside, what should all of the outside always add up to? What number? 360. So to get the measure of each outside angle, we're going to do 360 divided by however many outside angles there are. So if there's 4 outside angles, you're going to divide by 4. If there's 5, you're going to divide by 5. If there's 10, you're going to divide by 10. So you're going to divide by the number of angles, because it's essentially going to be divided evenly amongst all the angles. Hopefully that logic kind of makes sense. So I'll show you an example of it right now on the next page. So let me know once you're ready. Just flip the page. So notice it here says find the measure of one exterior angle in each regular polygon. Well, first we got to ask ourselves, how many sides does this have? So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's got 10 sides. Well, shouldn't all the exterior angles, what do they always add up to? What number? 360. How many sides are there? 10. So 360 divided by 10 is 36. So that's 36 degrees. That is the measure of one outside angle, one exterior angle. So class, you try B. B is going to be the same thing, except it's not 10 sides anymore. It's a little different. So try it out. We know on this next one, n is equal to 4. So if we want one exterior angle, we know all of them add up to 360. There's 4 angles. They're each going to be 90. Yeah, there you go. So let's try some trickier examples. How about something like this? We can find A. We can find A right now. How do I find A? So I know it's 180, right? So 180 menos 116 is 64. So we know that that's going to be 64. Now, how do I find B? And this part's a little bit tricky. Does anyone have any thoughts? You got to be really creative with this. I'm going to tell you what's going to help you are those symbols right there. What do those symbols mean? They're all the same. They're all congruent. You're absolutely right. How many outside angles do I have? Exterior angles in total on this shape? Yep, I have 6 of them, right? Let's think about it. 1, 2, 3, 4, 5, 6. All 6 of those together should add up to what number? 360. Okay, so we know that they should all add up to 360. Are there any of them that we know? We know 64. We know 80. We know that these 3 right here are the same. Do we know this last one? It's 90. So if we could subtract off 90 and subtract off 64 and subtract off 80, I think some of us are starting to see what we're going to do with this. We're left with 126. And what can we do with that? Divide by 3. And that gives us 42. So each one of these pieces, we know, is 42, 42, 42. But that still doesn't get us B. 180 minus 42. And that's 138. That's a good problem. That was a good one. I like that. Yeah, what's up, Jerome? This one? Yeah, we're going to do this one. Okay. I think to get this problem, we need to find X first. Class, I need you all to help me. Just say that out loud. Everyone. $72. 46. 98. So I know that all 6 of those things that I circled together, what do they add up to? 360. The outside always adds to 360. So class, write this down. Write x plus 2x plus 3x plus 72 plus 46 plus 98 all together is 360. Now let's start combining like terms. How many x's do I have? 6. Because 1x plus 2x plus 3x, that's a total of 6. How about all my numbers? Someone just grab a calculator. I'm sure someone already did that. What'd you get? No, no, you need me to do it for you. 70, 216. Now what can I do? Minus 216. I got 6x is equal to 144. Then I can divide by 6. X is 24, I believe. Is it 24? Yep. So now that I know that x is 24, I know that this is 24. Now the next one is 2x, right? So what's 2 times 24? 48. And what's 3 times 24? 72. So Jerome, now that you know those pieces, can you get A, B, and C? Yep. Because remember, all of these are linear pairs. So we'll get 108, 132, and 156. Good? Okay. So the backside is just 2 quick examples and then we're all done. I wanted to give you plenty of examples to look back to for when you do your homework tonight. How many sides does a regular polygon have if each exterior angle measures 18? What do you think, bud? You think 20? How'd you do that? Can you tell me? So you remember the formula 360 divided by n gives you 18, right? So you knew, well, what does n have to be to make that in 18? So what could I do to both sides? Times n times n. That gives me 18n. And then what could I do to both sides? Yeah, divide. And Jerome, you're absolutely right. N is 20. That's perfect. Good job. Now the last one, this one's a little trickier. It wants you to take it a step further. What if we knew that each exterior angle was 30? What is the sum of the interior angles? So what we're going to do is we need to figure out what is n, question mark. Then we're going to plug that into this formula once we figure out what n is. So we'll use the same thing, 360 divided by n, we know is 30. What is n going to be in this case? What's n going to be in this case? Give me a first step. I'll do the math. Just give me a first step. We can do exactly what we did up there. So just tell me what to do. So times by n. What did I do next? Do you know what n's going to be? Avery just told me it's 12. No, 13. 13? 12. Avery, you tried to trick me. Well, now that I know n is 12, I can plug it into this other one. So 180, 12 minus 2, that's 180 times 10, which is 1,800. So I try to do plenty of examples so that you all have things to look at when you're doing your homework. Okay? So I'm all done. feel free to pack up, and I'll see you all tomorrow.